In this lab, we'll be configuring switches and routers to establish a network between two subnets, and also we'll be configuring each switch and router to have telnet access so that they can be remotely configured by any PC. Also, we'll be checking the inbound and outbound of a packet as it starts from a PC at one subnet and goes to another PC in a different subnet. So let's start the lab by configuring the switch. First, we go into the enable mode and then into the configure terminal mode of the switch. Here we can optionally change the hostname of the switch. After this, we want the switch to have a password. So before someone can access this enables mode, so we write enable secret Cisco, which also encrypts its password. Now we want to configure its line console. So we write line console 0. Uh, a password is we want a password to be required at the login phase. So we write password Cisco and the phase at which we want the password to be asked, which is login. And then the console 0 interface has been successfully configured. So we write exit. After this, we try to configure the telnet sessions. So we write line VTY 0 to 4. VTY allows telnet or SSH sessions on the switch or router, and 0 to 4 indicates that 5 concurrent sessions are allowed on the switch. After this, we want the user to feel like he's uh, configuring the switch uh, at the line console. So we write login local, which allows him all the local access. After this, we want telnet traffic, so we write transport input telnet. As we are not configuring SSH, we are not including it here. After this, we set a username and password to enable the logging so that the logs can find which person used uh, the configuration to establish a telnet session. So username Rohit, password Cisco. After this, service password encryption encrypts all the password in the running configuration. We exit this and then we try to configure the interface past Ethernet 0 to 2, which is the interface between the switch and the router. We set the speed to 100 Mbps and then we configure the interface VLAN, which is the default VLAN in switch, to have the IP address 10.1.1.10, and the default mask is 255.255.255.2.0. Uh, this mask is changed so that limited number of devices can be accessible and subnetting can be allowed. As this address is a class A, was a class A address originally, this mask restricts the number of devices that the subnet has control over. Then we say no shutdown, as this we won't want this interface to go down, and then we exit. After this, we set the default gateway to 10.1.1.1, which is the IP address of router. We do this so that if switch doesn't understand anything, he just simply forwards the packet to the router. Show IP interface brief tells us about all the interfaces that the switch has, and whether and their statuses. So down indicates that it is down, and up indicates that it has been configured and, or is in connection with a PC. After this, we similarly configure the second switch. Then we go to the router. Here, things are safe till the telnet and service password encryption. After this, since each port of the router belongs to a different subnet, we have to configure all the uh, different subnets and the IP addresses, and also have to define a path. So let's start by defining the IP addresses. So first the interface gigabit Ethernet 0,0, which is the interface between the switch and router, is brought up. After that, we assign the IP addresses 10.1.1.255.255.255.0. Since this since the router's left side belongs to the uh, 10.1.1.255.255.255.0, 0 subnet, we give this IP address to the router and we end it. After this, we come to the second interface, which is the serial interface, which is connected to the router. We again bring this interface up and then we assign the IP address 30.1.1.1 to the router. And the IP mask is 255.255.255.0. After this, we assign the clock rate to 128000. Since this is a DCE connection, we have to assign the clock rate and the bandwidth is set to 128. After this, we exit. Now we want to define the IP route between the subnets. So the IP route is defined as follows. The first part indicates the destination IP subnet. So 20.1.1.0 is the address of the second subnet where the packet has to reach. After this, 255.255.255.0 indicates this net for the network's IP mask. After doing this, we need to define the port where the router has to send the packet in order to reach this destination. So 30.1.1.2 indicates the port of the router belonging to the same subnet. Uh, but this is the port of the other router, not the same router. Because if we give the IP address of the same router, then a loop will be formed and the packet will never reach its destination. So we specify the hop to be the next router's IP, but of the same subnet. After this, we exit. Similarly, we configure the right router. After doing this, let's try to ping the PCs. So while pinging, we first try to ping the 10.0.0.2, which is the switch from this PC. Uh, After doing this, since the switch doesn't have his MAC label state ready, the request gets timed out, and after the next three packets are get a reply. So the first packet gets lost. After this, we ping the router. Since the ping router is based on IP tables, it doesn't waste any packets, and all the four packets are reaching back to the PC. After this, we try to ping the second router. So ping 20.0.0.1. Again, we can see that no packet is lost and all the packets get a reply from the second router. Now we try to ping the right hand side switch. Now since the MAC tables of the switch aren't ready, two of its packets get dropped, uh, one at the first switch and the second at the second switch, and only two reply from packets are received by the PC. Similarly, when we try to ping the PC on the other subnet, we again see a drop of one packet since the MAC tables for those PCs aren't configured. Now let's try running a simulation based on this. So in this simulation, we'll be using only ARP and ICMP packets. So let's start the simulation. I already ran the simulation, so it is directly starting from the ICMP packet. Now here we can see that the ARP is being configured. Let's check the inbound and outbound of this packet. So here we can see the target IP, which is 20.0.0.3, and the source IP, which is 20.0.0.1. This is between the packets. The target MAC is still 0 because it doesn't know uh, the MAC address of the destination. Now the outbound PDU. Let's let's try the packet between routers. So here we can see the source IP is 10.0.0.3 and the destination IP is 20.0.0.0.3. Uh, since this communication is between routers, the MAC addresses aren't specified here. So that's how the inbound and outbound PDU of the packet loop. Now, since the router can only read up to layer 3, the above layers are blackened out since the router can't read this. Again, let's see the communication between switch and router. So that's how the packet looks. So that's the end of our lab.